Today it's our fifth video on hashing, and here we will discuss collision resolution technique using separate chaining. No, so if I say in video number third and in video number 4 we have discussed collision resolution technique using linear probing, and in video number 4 we have discussed collision resolution technique using quadratic and double hashing. Now in fifth video, this video will discuss collision resolution technique using separate chaining. Let's have a recap. That when we started with collision resolution technique, we have said that there are two techniques. One is by open addressing and one is by separate chaining. And in open addressing we have three methods. One is linear probing, one is quadratic probing, and one is double hashing. We have already discussed these in video third and video 4, and today in video number 5 we will discuss separate chaining. So what is separate chaining? So it is written over here, separate chaining. So I'll not read the text. Let me tell you, I'll not read this text. Instead, I'll show you some figure. So what actually happens here? What is collision? You know very well. When more than two keys are trying to take a same space, are trying to take a same index in hash table, then this is called collision. So what actually you do in linear probing, in double hashing, or in quadratic probing, you keep on finding the new available space. But here in separate chaining, you create a linked list. You actually create a linked list if there is a collision. So you create a link for every key. You create a link for every key, but if in case there is a collision, you start growing that linked list. You can see here, suppose what this hash table is representing. So this hash table will keep the address of head node of a linked list. Suppose my value 36 was coming at position 1. No, again some value came 93, which is again coming at position 1. So the hash table will keep the address of this first node, and this node, what is linked list keep the value, and address of next node will keep the address of next node, and here is null value. Fine. Similarly, there is only one value, and here we have two values. Similarly, if we get the same values who are taking the address index value as 1, we'll keep on increasing this line. So this is called what? Separate chaining. This is called separate chaining, where we'll take a linked list, so I'll not read it. So it's your job to read and understand. My job is to explain you what I'm trying to tell you. I'll also solve the question. Let's start. So collision resolution by separate chaining. So I'll read this small part. In chaining, we place all elements that hash to the same slot in a same linked list. This is what I already told you. If more than two elements are taking the same slot, will keep in the same linked list. As figure shows, which is the figure? This is the figure. Which is the figure showing that slot J contains a pointer. That is, every slot is containing a pointer which is keeping the head of every linked list, which is keeping the head, because you know what is head? The first node is represented by head. So this slot will keep the head address of every linked list. No, and we keep on growing. Okay, so this is, suppose you can see that k1 and k2 are coming to the same place, and then k5, k7, k2 are again, k5, k7 and k2 are again coming to the same place. And here we have created a doubly linked list. And what is the benefit of doubly linked list? The benefit of doubly linked list is that in doubly linked list you can go forward and you can come backward. No, so this is because we have taken doubly linked list. So this is all about explanation of figure, which I have already explained you. Now let's solve the question. Now you have a question that let us consider the insertion of these elements. Now you have to insert these elements in a chained hash table. A table is a chained hash table that is having a linked list. Let us suppose the function we are using is kmod 9. The m value is 9. You have to use this function now, and k is what? These values. Fine, let's start. The initial state of chained hash table, there is no value. Fine, what do you do? Suppose you have to store 5. What you will do? You apply h5. So what is 5 mod 9 is 5. That is, you will create a linked list. T5 to store the value of 5. Here you can see that I've created at 4th, 5th position. Suppose the address of this node is 200. So here it will come 200. Fine. Okay, now what will happen? Now I have to insert 28. So I'll apply 28 mod 9. I'm getting 1. And again, so again there is 19. So if I'll apply h19, that is 19 mod 9 is 1. Say though both are colliding, so they both are colliding. So what I'll do, I'll simply create a linked list. So what I'll do, I'll put first of all 19, that is first I've put 90, 28, and since 19 is coming, so I will increment 28 to the next node. I'll insert a new node over here. So now suppose the address of this node is 100 and address of this node is 200. So what will happen here, 100 will come and here you will have 200 and here you have null value. Fine. Similarly, hope you have understood what linked list is all about. There's nothing, we are creating a linked list. Now your remaining element are like this and we have solved using the same method, and finally you get the linked list like this. No, I'm not going to explain everything, I've already explained you. No, so this is how you get a separate chaining, where you are, what you are doing actually over here, you are resolving a collision using separate chaining. You are resolving a collision using separate chaining. You are resolving a collision using separate chaining.